Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we'll take a look at compound linear inequalities. These are linear inequalities that have two parts to them, or two inequalities to them. The first one, number 5, is an example of an intersection or AND inequality. We're looking for values of x that make 3x plus 10 greater than or equal to negative 8, reading that from right to left, while at the same time making 3x plus 10 less than or equal to 25. So we're looking for 3x plus 10 to be between those two values. And there will be some that are less than 25 but are not greater than negative 8. There will be some that are greater than negative 8 but not less than 25. We want them to be both at the same time. So we're looking for the intersection of those solutions. We can solve it like a linear inequality. Imagine if the negative 8 part wasn't there and you just had 3x plus 10 is less than or equal to 25. You would subtract 10 from both sides of that inequality. Well, here we're going to subtract 10 from all three branches of the inequality. Now I have negative 18 less than or equal to 3x less than or equal to 15. And again, pretend like the negative 18 wasn't there. If you had 3x is less than or equal to 15, you would divide through by 3. We're going to do that for all three branches. And because we're dividing by a positive 3, we don't have to worry about changing the direction of the sign. We have negative 6 less than or equal to x less than or equal to 5. And so in that set builder notation, it's simply the set of all x such that, and then we copy down the inequality. Negative 6 less than or equal to x less than or equal to 5. You can kind of think of it as between, right? We're looking for the values of x that are between negative 6 and 5, including negative 6 and 5, because of the equal signs. On the number line, zero's in the middle. Negative 6 is to the left, positive 5 is to the right. They both get the square brackets because those are included, and we shade between them. In interval notation from left to right, that's negative 6 comma 5, with brackets around both of those numbers. Okay, so this is an example of an intersection or an AND inequality. It has to make both of them true at the same time. The other example at the bottom of the screen, 2x minus 3 is less than 11, or 3x plus 5 is greater than or equal to 35. This is a union inequality or an OR inequality. To be a solution, it only has to make one of those two true. It can make both of them true, but it only has to make one to be included. We solve each inequality independently. So starting with 2x minus 3 is less than 11, add 3 to both sides, 2x is less than 14, divide through by 2, because it's positive, we don't worry about changing the direction of the sign, and we get x is less than 7. Now do the same thing for the other inequality. Subtract 5 from both sides. 3x is greater than or equal to 30. Divide through by 3. X is greater than or equal to 10. And again, it's still OR. We're looking for values of x that are less than 7 or greater than or equal to 10. In the set builder notation, we just copy that down. X is less than 7 or x is greater than or equal to 10. On a number line, we're going to graph each branch of that solution independently. So start with a number line, 0, 7, 10, like that. The first one says x is less than 7. So that's going to be an open parentheses, and we're going to shade to the left. For x is greater than or equal to 10, that's going to be a square bracket at 10, moving to the right. Now the interval notation, we have two intervals of solutions here, and we write them down separately first. So the first one is parentheses, negative infinity, comma, 7 parentheses. The second one is bracket 10, comma, infinity, parentheses. Parentheses goes next to a value if it's not included in the solution. It also goes next to negative infinity or infinity. A bracket goes next to a value that is included as a solution, like the 10 was here. Now between those two intervals, we're going to put the symbol U for union. And that's basically the mathematical notation for the word or. So it's either in the first interval or the second interval. Okay? These are compound inequalities, and we'll use these when we get into absolute value inequalities in a little bit.